This is GP model question, chapter number 7, question number 10. This talks about Shelton Corporation CFO, who has $1.2 million to allocate to the request from 5 different departments. Each department has some amount requested for normal functioning of the operations, but total fund is restricted at 1.2 million. That means they have only 1.2 million funds to diverse into different departments. So the CFO considers the request for Department 2 and 3 to be twice as important as those from Department 4 and 5. So if the importance from 4 and 5 is 1, 1, it should be 2, 2, and Department 1 will be the request from Department 1 to be twice as important from Department 2 and 3. So Department 1, it is twice as important as this, so it should be 4. Further, suppose the CFO wants to make sure each department receives at least 70% of the requested amount. Formulate a GP model for this problem. The typical fact is that why it is a GP problem? The amount requested may not be the same as amount allocated. So they want 450,000, but they will get somewhere approximately close to that. They won't be getting exactly the same amount. This is having all soft constraints. Here you can see this is at least 70% of the requested amount. So in GP model problem, what is our normal variables? We have normal fundamental variables, along with that 2 associated deviational variables. So our variable should be, let A1 is equal to amount allocated to Department 1. Similarly, A2, A3, A2 for Department 2, A3 for Department 3, A4 for Department 4, and A5 for Department 5. As you can see, there will be associated deviational variables. So deviational variables for A1, there will be D1 minus and D1 plus. So D1 minus represents the underachievement of A1 by that particular amount, and D1 plus represents the overachievement from A1, that is something in excess of A1. So we have corresponding for A2, sorry, A2, is for A2, These are the deviational variables. So after deviational variables, we have goal constant. What? Now, any amount in excess in underachieve minus excess should be equals to the requested amount. So this one. So the goal constant first. Before writing the goal constants, okay, we can do it anyway. What would be our objective? In our GP, our objective is to minimize the weighted sum of percentage deviation, right? This part. So here in this case, our objective is to minimize the deviation, weighted percentage deviation, that is so this is our objective, minimize the percentage deviation, same as this, and we can expand it and we can write as minimize, we can expand it, just write that T1 for A1 is 450, let's say in terms of 1000, so it would be 1 divided by 450 into W1 minus D1 minus plus W1 multiplied by W1 plus multiplied by D1 plus. So minimization of that, you can expand it, but we'll expand it once we understand what are the different weights, and after understanding which weights are zero, which weights have values, we'll write it. So what would be the goal constraints here? The goal constraints are, this is a goal equation, the fundamental variable plus underachieved deviation minus overachieved deviation equals to the target. So in this case it is let's copy one of them, A1 plus D1 minus plus D1 plus should be equals to 450. Similarly, we have for A2, A3, A4 and A5. For A2 it would be is equals to 310, and for A3 it should be 275, and for A4 should be 187.5, and for A5 it should be 135. This is the first set of constraints, goal constraints, and there will be other constraints as well. So in this question, what are the other constraints? Total amount constraint is the total amount constraint. So you can write here total amount constraint is A1 plus A1 plus A2 plus likewise till A3 should be equals to 1200. This is total amount constant. And we have one more constant, 70% minimum constant. Minimum constant. So that is like A1 should be greater than or equals to 70% of 450, and A2 should be greater than equals to 70% of 310. Likewise, till A5 greater than equals to 70% of 135. And the non-negative constraint is all these AI and DI, they are all positive numbers and greater than 0. AI comma DI minus comma DI plus all positive, that is greater than equals to 0. So we'll model the same things. We model the same in our Excel sheets. So this is our normal allocated variables. Make it as gray, and these are our deviational variables under and over. Total amount allocated is equals to sum of this, and goal is defined as, if you look at the first constant, the goal constant, goal is defined as amount allocated plus how much underachieved minus how much overachieved. I made a mistake over here, so this is not plus, this is minus. Overachieved is always deducted from the, see, if d1 minus is plus, that means d1 plus will always be 0. If d1 plus is there, then d1 minus will be 0. So this is minus, this is minus, this is minus. Okay, so we will fix the rows so that we can extend the formula. So now 70% target is equals to 0.7 multiplied by value. We'll fix the row again and we'll extend it. Okay. Now this is how much it is underachieved and its percentage. How can we get that? Underachieved percentage. That is how much deviation has occurred, how much underachieve has occurred over the target, isn't it? So this is equals to how much underachieved divided by target. to make the column rows fixed. Fix the rows, and this should be C. For the overachieve, it should be C6. Target. Let's turn the formula. Okay, right now this is not our concern. Okay. Similarly, for overachieve, its percentage would be how much you overachieve divided by target. And you extend the formula. Now, our objective. This is a bit tricky here. How we create our objective. There are other constants. We'll come to that when we create the solver. Our target here is in GP. We try to minimize the deviations, or what we can call it in other words is minimize the undesirable things. If we look here, what is undesirable? You have to minimize that. So it says request for department 2. Let's say the weight for department 5 and 4 is 1, and department 3 is 2, and department 2 is 2, and this is 4. These are the weights, but we are not sure whether these are underweights or overweights. So let's see where to put it. It says consider the request for department 2 and 3 to be twice as important from department 4 and 5. That means the fulfilling the request of department 2 and 3 is more important. Fulfilling the request of department 2 and 3 is more important means it is undesirable that we underachieve them. So, because we are trying to minimize the standard deviation of the percentage deviation, so we need to minimize the percentage deviation of its underachievement, because that is undesirable. So what we do is, this is underachieved weight. Alright, so this is 4, 2, 2, 1 and 1. And our objective function, and remaining these weights are all 0. And our objective function is to minimize the percentage deviation from minimize the weighted percentage deviation. So our objective formula is sum product of all these weights multiplied by this underachieved percentage. So this value has this part. To look at the objective function, 1 by Ti and Di. This part has Di divided by Ti, and this part has Wi. So when we did a sum product of this multiplied by this, we actually summed the percentage deviation of Di multiplied by Wi. W underweight is W minus, Overweight is W plus. Same is with under and over percentage. So this is our objective. And what are our constraints? So this is how we frame the objective, and in this part all the Wi plus, as you can see, they are all 0. So this part values are all 0. So we'll run our solver, data solver. Our objective is to minimize the undesirable, that is our objective. And by changing the variable cells, all the amount allocated and the deviational variables subject to the constraint. So first constraint is the goal constraint. That is, these values should be equals to the target. Goal value should be equal to the target. And what is our second set of constraints? Total amount constraints. That is, this sum should be equals to the total amount. And third constraint is 70% minimum constraint. That means all this amount allocated should be greater than or equals to 70% minimum. And the last constraint is non-negative constraint. Is all these deviational variables should be greater than or equals to 0. Now if we run the solver, this is our desired result. This much amount has to be allocated to the departments, and this is the deviation, like 30% deviation from underachieved for department 2, requested for 310, but you are just giving them the minimum required 217, and for department 3 it is 266.75 into 1000. Similarly for department 4 it is 30% deviation again, just meeting the minimum requirements. For department 5 it is 135, meeting all the target, no deviation. So this is how you minimize the standard percentage deviation in a GP, goal programming. We'll go to the next part of the question. We have implemented the model and have solved it, and this is our optimal solution. Now it says, suppose CFO is willing to allocate more than 1.2 million to this budget. That means he has some flexibility regarding to this total amount, and says exceeding the 1.2 million figure is being twice as undesirable as not meeting the budget request of department 1. Not meeting the budget request of department 1 is underachieving the request of department 1. Underachieving the request of department 1 is if the undesirableness is x, then exceeding the budget is 2x. So underachieving department 1 priority is 4. So overachieving the total budget should be 8. And this is 0. So this should be equals to this divided by target. Overachieve should be equals to this divided by target. And these two are our new variables, extra two new variables. Okay, mark them. And what would be our goal? Goal should be equals to total budget plus how much you underachieve minus how much you overachieve. So this value should be equals to this value. Alright, and our objective function will be is equals to sum product of all of this with the weights. Alright, so if you run the solver, reset the node here, fill the node. Our objective is to minimize the undesirable. So this is our undesirable. Just minimize it by changing the variable cells. All of this, comma, these two extra variables, subject to the constraint. So we have those usual constraints. First is goal constraint. Goal constraint is this value should be equals to the target, and this is our target. Second set of constraint is total amount constraint. That means this value, okay, this one is already included, so we can ignore it. So 70% minimum constraint. So this allocated amount should be greater than or equals to minimum 70% required value. And the last one is non-negative constraint. So all these values should be greater than or equals to 0, and these two values should also be greater than or equals to 0. Okay, now solve it. This is our solution for part 2, where bit C. So this is the optimal solution according to that. So you overachieve the total budget by 8.25 thousand, and this is the overachieve percentage, and this is the objective. So for you, this will be the result, like how much you allocate funds to different departments. Last part of the question: suppose the CFO regards all deviation from the original budget, including the 1.2 million available, to be equally undesirable. That means so the all deviations from the original budgets, including the 1.2 million available, to be equally undesirable. So all the weights are 1. So this is 1, this is 1, this is 1, and all related. It says what solution minimizes the maximum percentage deviation from the budgeted amounts. So here it is talking about a special case of GP that we have discussed, minimizes the maximum deviation. Here we are talking about minimax, the special GP objective. In minimax we have an extra variable called Q, which is the maximum of all deviations, and our target is to minimize that maximum deviation. But this D1 or DI minus plus, these are all individual deviations. But the question here is asked is to minimize the maximum percentage deviation. So this is our percentage deviations, all DI by the targets, di by ti is the percentage deviation. Our target is to make this as min-max variable. As you can see, I have deleted the formula. There is no formula here, and this will be a part of the decision variable. So I'll make this as gray for your convenience. And along with the existing constraints, we have one extra constraint that will say all this di by ti is less than equals to q, and q objective is to minimize the q. So go to data, solver, reset all values. Yes, your objective is to minimize q by changing the variable cells, comma, to comma q. Q is added here. Subject to the constraint. First constraint is the goal constraint, that is the values should be equals to the target values. Then we have 70% minimum, that is these values should be greater than or equals to the targeted minimum values. And last one is all these values has to be greater than or equals to 0. These two should be greater than or equals to 0. And the last one is all this percentage deviations should be less than or equals to q. That means q has to be the maximum deviation. Alright. Okay. And your objective is to minimize that q. So this is the final solution. That if you can see, this is all 6.16. So we have 6 variables, and it is evenly distributed over all the variables. 6.16 into 6 is almost close to 100%, and this is the amount allocated to each department. And yes, this is the solution. Thank you.